Hello everybody, welcome here in the studio in Marrakesh. My name is Rik Marselis and I'm going to tell you about quality engineering in today's cross-functional teams with TMAP. At first I would like to start, apologies for the little slow start, but as you know, here in Morocco we use camels to get everything done, so it took a little bit longer. Anyway, let's quickly start here on the A4Q Testing Summit. So, what are challenges of IT today? Well, today the IT challenges start with the business. And business people, they want business value. So they don't ask for IT systems because that you need IT systems is a no-brainer. They ask for business value. And they want quality at speed. Meaning they do want to have quality, but also they don't like to wait. And this brings challenges to the teams. So to meet these demands of the business, quality engineering is everyone's responsibility. And you need to integrate your QA and testing in the whole process, but also in all the people that are involved. Therefore, the focus in IT delivery is organize high-performing cross-functional teams. And what they are, I'm going to explain, of course. But in general, in DevOps, it is about teams that build IT systems and run IT systems. Also, you want to automate everything. Well, with automate everything, I always say, as long as it is useful. And I'll get back to that towards the end of the presentation. So it's about high-performance IT delivery. And what is that? Well, it is an approach that enables cross-functional teams to continuously improve the products, the processes, and the people that are required to deliver value to the end users. So there's a number of important things here, and during this presentation, I'll go into details of each of them. So first, let's look at high-performance IT delivery. Now, there are many possible ways of IT delivery, and traditional we have sequential IT delivery like waterfall and V model. Today, most organizations would like to have or already do have high-performance IT delivery with Scrum and DevOps, and also, we see a lot of organizations having a demand-supply model, which basically is a combination of some characteristics of V model and some of Scrum or other ways of doing Agile. And of course, there's Agile at scale, for example, with the Scaled Agile framework. Now, the focus of the renewed TMAP is high-performance IT delivery with Scrum and DevOps. But the agile mindset goes to both high-performance IT delivery and hybrid IT delivery. So what I'm going to tell also relates to that. Then a little bit about DevOps. So you may wonder, what is DevOps? And probably you have seen DevOps Infinity Loop before. And we have made the basic DevOps Infinity Loop, which consists of 6 activities. Plan, where you, of course, make plans, but also describe, for example, your requirements. Code, where you make program code, but also other things like infrastructure as code or documentation as code. Then we have integrate, where we integrate the new and changed things with the already existing IT systems. And then we deploy to the live environment, and we operate and make sure it keeps running. And in the middle, you see the monitor activity, which monitors both the dev side, where there is development, and the ops side, where we have the operations. So that together makes DevOps. And now you may wonder, I don't see any testing here. Well, you've seen that correctly, because testing is all around. The same goes for quality. Quality is a thing that applies to everything you do in a DevOps IT delivery, and moreover also in IT delivery in general. There has been a lot written about DevOps, and a lot of people have many different opinions. So I like to start with the DevOps Handbook. And in the DevOps Handbook, they describe 6 DevOps principles. And as you may notice, these principles are very nicely aligned with the 12 principles of the Agile Manifesto. So DevOps and Agile go really hand in hand. And then you may wonder, what is DevOps? And there are quite some definitions. We looked at all these definitions, took them together, and came up with this. DevOps is a cross-functional systems engineering culture. So DevOps is a culture, a way for people to work together. And the DevOps culture is based on the Agile mindset. So the Agile Manifesto fully applies. And it can be supported and implemented by, for example, a Scrum framework. So Scrum is a framework with an Agile mindset that can be used to implement a DevOps culture. By the way, you can also use other ways to implement DevOps. An example that is more and more used is site reliability engineering, the way Google implements DevOps. But most organizations still keep Scrum, the Scrum framework, for that. So we come back to high-performance IT delivery, and I would like to go into a little bit of detail of the cross-functional teams. So a cross-functional team is a team where multiple roles work together to pick up all the tasks that the IT delivery team must do. So we have people that do business analysis tasks, development tasks, operations tasks, testing tasks, and we also have people that support the team, like a product owner and an agile coach or scrum master. But in a cross-functional team, nobody has the monopoly on a specific task. So it's not that, let's take an example. Suppose I'm testing something and I see a simple programming flaw, and I think I can fix that myself. Then a developer can't say, hey, Rik, you're the tester, you can't do that, because as a team, everybody is allowed to take up any task. However, the team together takes joint responsibility for quality. So if I change something in the code, then another team member should at least check if I did a good change. The other way around, if a very experienced developer creates something, still somebody from the team should check what they have created, because the team takes responsibility together. And by taking responsibility together, the team also can work in a more efficient way. And one of the things with that is that in the beginning of a sprint, if you would work Scrum, you have a 2-week sprint, for example, then in the beginning of the sprint, you need to do quite a bit of business analysis tasks and probably not so many operations tasks. Whereas towards the end of a sprint, often the emphasis comes on testing and operations. And then all the people in the team work on the tasks that are relevant at that point in time. So that's about cross-functional teams. Then let's have a look at value, because we do IT delivery for a purpose. So we look at the scope of business delivery. We want to deliver something to the world, to the business. And the first step is value definition. So we define the value that we're striving for. And then we have the scope of IT delivery. And the first step is we detail the objectives that we need to reach within IT delivery to be able to get the pursued business value. And these objectives are supported by quality measures. So quality measures are activities that you do to build quality in. for example. These are the so-called preventive quality measures to build quality in right away. And then if you know your objectives, you want to know if you are reaching your objectives and creating your business value. And that's where indicators come in, because indicators help in determining if you are reaching objectives and business value, and measuring these indicators is mainly testing. So that's where testing comes in the picture. And with testing, we supply information based on measuring these indicators, and this information goes to your stakeholders, for example, the product owner, and they determine whether they have enough confidence to put the IT system live. So it's confidence in the pursued value, the value that they want to have. And if they have enough confidence, then they will decide to go live, and then the business people and the end users, they will experience the real value. And that's why we call this the voice model. We have value, objectives, indicators, confidence, and experience. Now, when end users experience the real value, something interesting happens, because then they start thinking of new possible value they want, and then we get this value improvement loop. And if you really work DevOps with a Kanban approach, you can deliver new business value multiple times per day. But if you work in, for example, Scrum, you have a 2-week sprint, then the value improvement loop is every 2 weeks. And if you have a traditional IT delivery model, then it will be a month or even longer. So the voice model always applies, but today often we look at high performance IT delivery or hybrid IT delivery with shorter cycles. And that's where you see the value improvement loop. So that's a little bit about value. And I could tell you much more, because most of the things I tell are based, or no, everything I tell, by the way, is based on the new TMAP book, Quality for DevOps Teams. And it's more than 400 pages. So I can't by no means tell everything I would in these 40 minutes or so. So let's quickly go to a next thing, and that is the products, processes, and people. Now, quality often is perceived as the quality of products, but we also would like the products, the quality of processes and the quality of people, because sometimes I come along people that say, no, we don't have time for training courses because we need to deliver products. But probably if you do a training course, you will be more efficient and effective in delivering your products. So quality is not just about the products, it's also about processes and about people. Now, TMAP is the body of knowledge for quality engineering and testing. And we have a nice website for that. But it all revolves about quality. For example, with the quality characteristics. And what you see here is the ISO standard, the 25010, but we added a little bit to it. For example, based on this book, the book Testing in the Digital Age, which was published in 2018, which is about AI, testing of AI and testing with AI. And then when testing AI, you notice that the original quality characteristics are still very valid and valuable, but also you need to have more things because AI is quite specific. Take, for example, personality. If you are testing a chatbot, you want to know if the chatbot's personality aligns with what you need to do in your organization. And another thing that we just added in the 3rd edition of the book is sustainability as part of quality in use. Now, I could tell many more things, but just have a look, for example, on tmap.net, the website where we have this kind of information. Then high performance IT delivery is about continuously improving. And of course, the improvement is about improving products, if you work in different cycles, you make new things for your product, but also you do refactoring, for example, and that is done in your IT delivery processes. So your IT delivery processes are very important for your continuous improvement, and you also need to improve your processes all the time, and you need to look at the skills of the people, because the more skills and knowledge and experience people have, the better they are able to deliver the right products. Now you may wonder, what is quality engineering? And when we started with this book like 5 years ago, I had never heard of quality engineering before. So in 2019, we started looking into, and ultimately I learned that quality engineering is a very useful concept. So now you still may wonder, what is it? Well, our definition is this. Quality engineering is about team members and their stakeholders, so that's the cross-functional team, taking joint responsibility. That's an important thing. Yeah? They take responsibility together. So it's not, I do this piece and then I throw it over the wall and somebody else does something. No, we're in it together. And what the team does is continuously deliver IT systems with the right quality at the right moment. So it's not about the highest possible quality. It is about the right quality in this situation at this moment to business people and their customers. And quality engineering is a principle of software engineering concerned with applying quality measures to assure the quality of IT systems. So quality measures are also an important concept. And there are 3 groups of quality measures. And the first group of quality measures is about building quality in and delivering it right first time. These are also known as preventive quality measures. They make sure that you have the right quality from the start. But within quality engineering, of course, we have testing. And testing is about providing information to the stakeholders so that they can establish their confidence in the quality and confidence that the remaining risks are manageable. So that's testing, also called detective quality measures. And then, of course, we have corrective quality measures, which are, for example, in the ops part of DevOps, where you do things like proactive quality improvement. And one of the things that ops people use are feature toggles to influence the quality. But other things here may be proactive refactoring of code to make sure that code maintains the right quality in your situation. So here you see the 3 groups: preventive, detective, and corrective quality measures. Then testing. Over the years, there have been many definitions of testing. Ooh, my book falls over. Don't worry. So over the years, there have been many definitions of testing. If you like to know about the history of the definition of testing, then have a look at my blog, which is at the TMAP website. But for now, I'll tell you what the definition is that we like to use today. And I'll first read it out to you, and then I'll describe it a little bit. So testing consists of verification, validation, and exploration activities that provide information about quality and the related risks to establish the level of confidence that a test object will be able to deliver the pursued business value. So it all starts with a test object on the left. And for a test object, we do 3 things: verification, validation, and exploration. Now, you may have heard in the past that testing is about verification and validation. And that's very true. Why then did we add exploration? Let me give you an example from security, the security domain. Suppose you want to do security testing and you do verification. Then you check, for example, when I log in, do I need a login code? Do I need a password? And will it block if the password is wrong several times? Also, you do validation. For example, the manager of a department, does a manager have a higher security level than a normal employee, because you have different things to be able to do different kinds of work. But then comes exploration, and that's the thing that white hat hackers, the ethical hackers, do, because they look at the system and try the things that were not intended. So verification often looks at the requirements, validation looks if it's fit for purpose, but exploration looks at what else can we do. And of course, with security testing, it is, for example, to see what could hackers do with my system, but also other parts of quality can be checked this way. So we have verification, validation, and exploration. All of that together gives information about the quality level. So do we have the right quality and the related risks, the quality risks? And all that information together is used by the stakeholders to get confidence that the pursued business value will be achieved. Now, to do quality engineering and testing, you need many activities. And TMAP exists for more than 25 years. So a lot was known already. But one of my things when we started writing this new book was that, for example, reporting was not very explicit and obvious in the traditional TMAP. And then my colleagues said, yeah, but there are more things that are not very clear, explicit, and obvious. And you still need to do that. And we made a list and we had more than 50 things that you need to do for quality engineering and testing. And then we started grouping them. And now we have 2 groups of topics. And we have 11 organizing topics. And the organizing topics have a multi-team scope. So they look at things that are done for multiple teams. Things like orchestration, arranging, planning, preparing, controlling. So that goes for multiple teams. Let's, for example, look at the first organizing topic. It's quality and test policy. Well, you wouldn't want each individual team to make their own policy. That's not what policies are for. On the other hand, we have the performing topics. And performing topics are within one team. So they are operational QA and testing activities. Now, this is not a totally black and white picture because, for example, under organizing, you see estimating and planning. Well, you have, you want to align your estimating and planning across multiple teams. However, each individual team will make their own planning, of course, and that may be a document, but it may also just be in their Scrum board, their task board, where they have all the tasks and schedule when the tasks need to be performed. And on the other side, with the performing topics, we have things like reviewing of requirements or test data management or test executions, things that you basically do within your team. But if you are involved in end-to-end testing, then probably you would have test execution over multiple teams. So it's not totally black and white, but it is very useful to have all these topics, and none of the topics can be left out. On the other hand, some topics are looked into once or twice a year, like, for example, quality and test policy, and other topics are addressed every day. So let's have a look a little bit into quality measures. But before I do that, I first want to check how much time do we still have, because it's past now. We have about half an hour? No, 10 minutes. Yeah, okay, so we have 40 minutes. So yeah, okay, then I know what to do. So I would like to pick out a few quality measures, and I can never discuss all of them, because if you would look on the tmap.net website, where there is the quality engineering strategy, it's a template for a quality engineering strategy table. And in that template, you will find over 100 different quality measures. So you can imagine I can never do 100 quality measures in less than 10 minutes. So I'll grab out a few. And first, explain what is a quality measure. It's a group of activities that is aimed at achieving a certain level of quality. So quality measure is about activities. But the word measure in English is sometimes confusing because one of the examples of quality measures is testing. And testing is a activity, a quality measure, that measures the level of quality. Are you still with me? So a quality measure that measures the quality. Yeah, and that's why it's sometimes confusing. Therefore, we have this definition. I already explained about build quality in with preventive quality measures, demonstrate the quality level with detective quality measures, and improve the quality with corrective quality measures like refactoring. And I'll quickly go to the first row, which is development. And one of the things that development can do to improve IT delivery is do mutation testing. Now, if you wonder, I never heard of mutation testing before, I can imagine, because when I started working on the book, I also hadn't heard from it before. And on the book, you see 4 authors. One of them, Berend van Veenendaal, he is a backend developer. And Berend mentioned mutation testing to me, and I said, what's it? Well, mutation testing doesn't test the product, it tests the test itself, and it's basically used in unit testing. Suppose this is your line of code. We only have one line of code. If a larger than 10, print yes and if. And then you may have created 2 test cases. You test it with 10 and you expect no print. And you test it with 11 and you expect print yes. And if the programmer did a good job, both will pass and you think you're fine. But if your programmer didn't do a good job, then what might happen? For example, they may have programmed if A is unequal to 10, print yes. You would not have found it with only 2 test cases. You need a third one where you test 9, and then you expect no print. On the other hand, the programmer might also have programmed if A equals to 11, print yes, and you wouldn't find it with these 3 test cases, so you need a fourth one. A is 12 and the expected result is yes. And if you know boundary value analysis very well, you already recognize that in the end, this could have been done with 4 boundary value analysis. On the other hand, with mutation testing, you also look at risks. So how big is the risk that my developer does these kind of odd things? So, but anyway, mutation testing is used for this. And basically it's done by tools, by the way. Yeah? So you don't do mutation testing manually because that would take way too much time. Let's quickly move to the next one. Let's do something with testing. Now, testing basically has a goal to look at the pursued value, requirements, specifications, and quality risks. And then you do some kind of test design. And it can be coverage-based test design using test situations, test cases, and test data that are put in test scenarios and test scripts. And then you execute the tests. And very important, you assess the outcome. And that may be done with test design techniques. And we have investigated test design techniques, and there are approximately 25 to 30 test design techniques in the world. And all of them fit in one of these 4 groups. So you have process-oriented test design, condition-oriented, data-oriented, and appearance-oriented. And it's very important that you know at least a test design technique from every group. Because if you have a process-oriented problem and you try to solve it with a data-oriented test design technique, it will not work really well. So therefore, you should know at least one technique from every group. And we have experience-based testing, which we don't call techniques, we call them approaches. Because in a technique, if 2 people do the same technique, you get the same test cases. In experience-based testing, it differs because everybody has different experience. And then we say, always combine experience-based with coverage-based testing. So don't just do one or the other, but combine them. Now in TMAP, we think these 16 test design techniques are most useful, most necessary. There are more techniques, but these are the core techniques that people could use in the 4 groups. And by the way, if this goes too quick, and I can't go in details of all of them, so if it goes too quick, I will put the presentation on SlideShare later, and also it will be recorded, of course. So let's quickly move to the organizing role, where you can have your product owner or Scrum Master or Agile coach, and they can use the so-called quality engineering strategy. I already mentioned the Excel template that we have on tmap.net, the website, and the goal is to have built-in quality, because the quality engineering strategy relates to what quality measures will be done for your IT delivery items, and to indicate the intensity of your quality measures. Because I told you there are more than 100 quality measures, but some give a higher coverage or another way of cover a high intensity than others. And usually it is risk-based. So I'll quickly give you an overview. I could tell half an hour about the template alone, but at the beginning of the template, you have IT delivery items like user stories and features. Then you determine the quality characteristics. And we were talking about the quality attributes from the ISO 25010 standard already. And you define the risk class, where, for example, A is a high risk, B is a medium risk, C is a low risk. I generally have only 3 risk classes, because with your test design techniques, you can't differentiate more than 3 anyway. And then you will have columns for build quality in, demonstrate the quality level, and improve the quality. And there, first with bullets, you indicate whether you want to have low, medium, or high intensity. And then you select the adequate quality measure with that. Well, that's what I can tell in this short time. Also, you need orchestration. Orchestration, for example, across your CI/CD pipeline, which is essential when doing DevOps. And if you do an end-to-end process with multiple teams who all have their own build pipeline, then they together will deliver from the various build pipelines to one release pipeline, where you will do the business testing, and that is testing from a business process perspective. Now, CI/CD pipelines are about automation, and people always say automate everything. And then I would like to say this wisdom: it's seldom wise to automate nothing. So automation is good, but it's never wise to automate everything, because probably it will not be efficient or effective. So automate what is useful, but don't see automation as a goal in itself. And do remember that people also have valuable qualities and valuable skills. So, looking at the time, I would first want to do a short conclusion and then see if we still have time for questions. Do we, by the way, have questions already? Okay, if you have questions, you can put them in the chat. And I'll first tell you briefly my conclusion. So one of the conclusions of quality engineering is that testing is no longer the messenger of bad news. Instead, quality engineering enables the adequate quality level, the right quality that delivers business value. Now, if you would like to know more, because like I said, I can't tell as much as I would like to, we have, of course, the book, we have the website tmap.net that you see in the upper corner here, and we have some training courses with certifications. The first one is Quality for Cross-Functional Teams for everybody involved, including business analysts or developers, operations people, of course, testers, but also even product owners and Scrum Masters. Because often I see that if I advise, for example, a business analyst to do a testing course, they don't want to do that, but they do want to look into quality. And I told you about the performing topics and the organizing topics. We have 2 more in-depth training courses for these 2 things. And of course, it's not just about the training course. Also, you would like to show that you have the knowledge and skills. So there are exams in the certification scheme with proper syllabi, which are managed by ISQI in partnership with GUSC. And you can find everything about TMAP at tmap.net and everything about the certification at tmapcert.com. If you wonder how big is TMAP, TMAP already exists for more than 25 years, but the renewed certification scheme based on the new book already has people certified in at least 15 countries. And nowadays, exams are done online, so maybe there are even more countries, but we didn't know the country where people were from. So we have people certified across 4 continents. And if people in Australia are looking, well, I would welcome you as well. We have nobody in Australia yet. I already talked about the tmap.net website, where we have, for example, all these templates. They are currently available in English and a number of them already in Spanish. And we are working on French. By the way, the TMAP training courses, the first one is already available in French. And the TMAP glossary is available in 5 languages. If you would like to follow TMAP on LinkedIn, we have a LinkedIn fan page, like we want to call it. And that brings me to the end of the presentation. So I gained a little bit of the time we lost at the beginning back. And hopefully we still have a possibility to answer 1 or 2 questions. Now I'm looking to... No. We don't have time to answer questions anymore. Well, what a pity. My email address is on this slide. If you would like to ask questions, just send me an email. Thank you very much for your attention and see you around in the wonderful world of quality and testing. Thank you.
Thank you so much for your amazing presentation. We appreciate your time and we look forward to seeing you again. Please be sure to tune into our Facebook channel, YouTube, LinkedIn, as well as find all of the presentations and live streams on Skills Club. Thank you and goodbye.